So, building a web server, it's something pretty much all of us have to do, right? But the way you build it, well, that can make all the difference. Today, we're going to dive into Effect's HTTP platform. We'll see how its really unique, composable design helps you create apps that aren't just powerful, but are also incredibly clear and easy to maintain. Let's get into it. You know, a modern web app can feel like this giant, complicated machine. It's got 1,000 moving parts. So to make sense of it all, we're going to use a pretty simple analogy. Think of your app as a digital post office. Every single HTTP request is just a piece of mail, and our application's entire job is to receive it, sort it, process it, and then send back a reply. Okay, so where does all this magic actually live? Well, if we peek inside the Effect monorepo, you'll see a whole bunch of packages for AI, for CLI tools, you name it. But our focus today is right here on @effect/platform. This is the one that gives us all the core building blocks for our digital post office. All right, let's start the tour. What we're going to do is follow the complete journey of a single HTTP request, right from the moment it hits our server to the second a response gets sent back. Think of it like we're tracking one single letter as it moves through every single step of our post office. First stop, the building itself. In the Effect world, this is the HTTP server. Its job is super simple. It just listens for incoming mail. That's it. It's the front door. It doesn't process anything. It doesn't read anything. It just accepts the mail and passes it inside to be handled. So what is this mail that just showed up? Well, it's an HTTP server request. And just like a real letter, this thing has everything we need. It's got a destination address, that's the URL. It's got sender info, those are the headers. And of course, it has the actual message inside, that's the body. It perfectly wraps up a single incoming request. Okay, so the letter is officially inside the post office. What's next? Well, we need to figure out where it's supposed to go. This is the mail sorting phase of our journey. The main idea here is actually really intuitive. A mailing address like 123 Main Street tells a postal worker exactly which house to go to. A URL path like /users/123 does the exact same thing for our app. It's a unique address for a resource we want to get to. The component that reads this address is the HttpRouter. You can think of it as the central sorting room of our post office. It looks at the request's method, is it a GET or a POST, and it looks at its URL path. Based on that, it knows exactly which department, or what we call a handler, is supposed to take care of this specific piece of mail. And the way you actually do this is just brilliant. Defining a new route is exactly like setting up a new mailbox for a new address. With just this one line of code, we're telling our router, hey, anytime you see a GET request for the address /hello, I want you to give it to the handler that just replies with hello world. It's so declarative and so easy to read. But wait a minute, what happens before a letter gets to its final destination? A lot of the time it has to go through some standard processing, right? Like getting a timestamp or a security check. In effect, this is where middleware comes into play. I mean, any developer building a real app runs into this question. How do I handle things that apply to a ton of different routes? Do I really have to copy and paste my logging code into every single handler or check for an auth token everywhere? No way. That would be a complete nightmare to maintain. The answer is HTTP middleware. And you can think of this as our post office's assembly line. Every single piece of mail can be set up to pass through a series of stations. One station might log the request, the next one checks security credentials, and a third one adds a special CORS approved stamp. It's how we handle all those common concerns, but in one clean, elegant place. So here's the crucial part. This all happens in a very specific, predictable order. A request comes in, first it hits the logging station, then the CORS station, then the auth station, and only after it passes through all of those does it finally reach the handler it was meant for. This creates a really powerful pipeline that's super easy to reason about. And the best part is, you don't have to build all of this from scratch. Effect comes with a bunch of common, pre-built middleware stations right out of the box. Things for handling CORS, for logging requests, or even for dealing with X-forwarded headers when you're behind a proxy. You just plug them into your application, and you're good to go. Okay, so our request has been sorted and it's been processed. It has finally reached its destination, the handler. Now the handler can actually do its job, which is to craft a reply and send it back. First things first, a handler needs to read the mail. And the HTTP server request object gives us a whole bunch of powerful schema-based tools for this. Need to parse and validate a JSON body? There's schema body John. Handling a form with file uploads? Use persisted multipart. It makes pulling information out of the request incredibly straightforward and type-safe. Once the handler has done all its work, it needs to write a reply. And just like with requests, Effect gives us a really simple and expressive way to do this. You can send back plain text, some JSON, a file from your computer, or maybe just an empty response with a specific status code, like a 204 no content. Each function just builds a perfect, well-formed response. So we've followed our letter all the way through the digital post office. We've seen how every single piece, the server, the router, the middleware, the handlers, each one has a single, clear job. And this really brings us to the final, most important point. By building our apps from these small, composable, type-safe parts, are we just building powerful systems, or are we also building systems that are fundamentally easier to understand, easier to test, and easier to maintain? That, right there, is the core promise of Effect's platform.